This is the second video for accelerated geometry on section 16-2. And today we're going to focus on solving exponential and logarithmic inequalities, which means now instead of having an equal sign, they're either going to have a greater than, less than, greater than, equal to, or less than or equal to. In this section, we're going to be writing our answers using interval notation. So if your answer comes out to be where they're both less than, or I'm sorry, if you have one is less than or equal to x, is less than or equal to another number, then because there's an equal sign here, you have a bracket. If there's not an equal sign, then it's a parenthesis. That's the key thing about interval notation, is if it can equal, there's a bracket, and if it cannot equal, then there's a parenthesis. And we can never equal infinity. So if positive infinity or negative infinity is part of your answer, then it's always going to be a bracket. I'm sorry, it's always going to be a parenthesis wherever the infinity is. So for example, if you want to say that your answer is x is greater than 5, then that means you would start at 5, it's not equal to it, and it would continue on and on and on to the right, which would be to positive infinity. If you were to say x is less than 5, then you would start at negative infinity and end at 5, but neither of them would be equal. If you were to say that x was greater than or equal to 5, then you would start at 5, but since it can equal 5, this would now be a bracket, and the infinity would still have a parenthesis. If you had something like 2 is less than x is less than or equal to 4, then you would start at 2 and it's not equal to, so it's a parenthesis, and end at 4, and it is equal to, so you would have a bracket. Solving some examples for inequalities. Okay, so our first question is there a way to write them with the common base, kind of like what we did yesterday? So can I write 625 with a base of 5? And the answer is yes. So I have 5 to the x minus 4. We're going to drop the inequality sign for now and put equals. And we can rewrite 625 as 5 to the 4th. Now they have the same base, and this is just like what we solved yesterday. So we can say the exponents have to be equal, which tells me that x would be 8. Now, this is not your final answer because this is not an equation, this is an inequality. So what we're going to do is we're going to create a number line. The number that you solved and got is going to go in the middle, and then you're going to pick test points. So we're going to plug in a number less than 8, say 7. So 7 minus 4 would be 3. So 5 to the 3rd, is that greater than or equal to 625? And the answer is no. So we're going to put an x here. Then we're going to pick another number greater than 8. So if we pick a number greater than 8, say 9, we would have 5 to the 9 minus 4, which would be 5 to the 5th. And since 625 is 5 to the 4th, 5 to the 5th would be greater than or equal to 625. So then you would have a check. So then I know that my answer starts at 8 and goes everything to the right of 8. So I would have from 8 to infinity. Remember, you can never include infinity, so that's always going to be a parenthesis. Now for the 8, go back to the original problem. There's an equal sign here, which tells you that there's going to be a bracket. And so your answer would be a bracket, 8, comma, infinity, parenthesis. Example 2, it's still an exponential that we're solving here. So I'm going to drop the inequality sign for now, change it to equals. And there's no way to write these with a common base. However, we do know our log properties, and remember that anytime you're working with exponential and you're stuck, you can always convert it to log. So I can rewrite that as log base 7 of 18 equals 3x minus 4. I can use change of base formula here, which is log of 18 divided by the log of 7 equals 3x minus 4. Type this in your calculator and round it to decimal places, and you should get about 1.49. Add 4 to both sides, and divide by 3. Now again, this is not my final answer. That just gives me the number I need for my number line. If I pick a number less than 1.83, 0 would be an easy number to plug in. So 3 times 0 would be 0, minus 4 would be negative 4. So is 7 to the negative 4th less than 18? Yes. Pick a number greater. We're going to pick 2. So if I plug in 2, 2 times 3 is 6. 6 minus 4 is 2. So is 7 squared less than 18? 49 is not less than 18. And if you notice on the original problem, there's not an equal sign here, which means my answer, if you notice, it's on the left side now. So I'm going to start at negative infinity and end at the 1.83. And there's not an equal in the original, so there's not going to be any equals down here, especially since you have an infinity. So this would be your final answer. Solving logs. We're going to do the same thing we just did, except now instead of being in exponential form, we're in log form. So in order to get the log by itself, the opposite of subtraction would be adding. And again, I'm going to change this from the beginning to an equal. I'm going to add 3 to both sides. I'm in log form and I'm stuck, so I'm going to convert it to exponential. So that tells me 3 to the 4th equals x, and 3 to the 4th in my calculator is 81. Now, we are not done. If you notice, the first 2 examples were exponentials. We didn't have to worry about domain restriction with exponentials, but you do with logs. So you also need to find your domain restriction, which means you're going to look at what you're taking the log of. In this case, you're just taking the log of x. So x has to be greater than 0 because you can't take the log of a negative or 0. So now on your number line, you're going to have 2 checkpoints. You're going to have the 0 and the 81. But we already know it can't be less than 0, so this is automatically going to be an x. So if I pick a number between 0 and 81, 1. So we'd have the log base 3 of 1 minus 3, is that greater than 1? So in my calculator, the log of 1 divided by the log of 3 type that in your calculator, subtract 3. Is that greater than 1? And so you should get negative 3 greater than 1, which is not true. So we're going to put an x here. Then we're going to check a number greater than 81, 82. So we would have the log base 3 of 82 minus 3, is that greater than 1? So log of 82 divided by the log of 3 minus 3. And you should get 1.0111 greater than 1, and it is. So now I can see it's everything to the right of 81. There's no equal sign, so it's parenthesis 81, and everything to the right would be going towards positive infinity, and you can never equal infinity. Pause the video and give example 4 a try for yourself. Okay, so looking at example 4, first step is to change the inequality to equal and solve it like we did yesterday. So once I change the greater than equal to just equal, we have the single log on one side and we're stuck, so we can convert it to exponential. 9 to the 3/2 is really 27, and then the opposite of subtracting is addition, so we should get that x is 35. But this is a log function, so it has a domain restriction. So then I said, okay, well, x minus 8 has to be greater than 0, which tells me x has to be greater than 8. Make your number line. The two numbers we have are 8 and 35. We know it can't be less than 8 based on this right here. Then I picked a number between 8 and 35. I chose to plug in 10. So 10 minus 8 is 2. So it's really the log of 2 divided by the log of 9, which comes out to be 0.315, is not greater than or equal to 1.5. So I put an X there. Then I picked a number greater than 35. I chose 36. 36 minus 8 is 28. So it's really the log of 28 divided by the log of 9, which comes out to be 1.516, which is greater than or equal to 1.5. So I put a check. So now that I have my check that I need, I know that I'm going to start at 35, and it's going to go to infinity because it's to the right. I could never include infinity, but if I go back to the problem, there is an equal sign, so that means this is going to be a bracket. Okay, let's look at how to solve graphically. So first thing you're going to do to solve graphically is to create your graph. Now remember, in order for this whole side to go in y1, what you're really going to type in y equals 1 is the log of x divided by the log of 2. You have to use the change of base here. And then y2 is going to be 3. So go ahead and pause the video for a second. Type this in your calculator. Now your graph will look slightly different because I've zoomed in a little bit here. And then what you're going to do is you're going to go to Second Calc, Intersect, and then you're going to hit Enter, Enter, Enter. And you should see that the graph intersects at 8, 3. Now, I want to know, when is the log function, which in this case is the blue, below 3, which if you notice, it's everything to the left here. However, it is a log function, therefore there is a domain restriction. So I highly suggest that you start with making that domain restriction. And in this case, it's just the log of x, so then x has to be greater than 0. And you know the intersection is at 8, which really tells you that your answer is between 0 and 8. And there's no equal here, and you can never equal your domain restriction, so then both of them are going to be parentheses. And there's your answer. Now remember, this is interval notation. This is not an ordered pair. You're not saying that the answer to the problem is at the ordered pair of 0 to 8. You're saying that from the interval of x equals 0 to x equals 8, the log function is below the line y equals 3. Pause the video and give example 6 a try for yourself. Okay, so in y1 you should have typed this function, log of x minus 2 divided by the log of 5, and in y2 you should have 1/3. When you calculate the intersection, you should get 3.71 comma 1/3, and I went ahead and found the domain restriction just in case I need it. So this is saying when is the log, which in this case I have graphed in blue, above my line, which in this case is in red. So if you notice, it's this little piece right here. So it looks like it starts at the intersection and everything to the right. So I'm going to start at the intersection point of 3.71, and everything to the right would be to positive infinity. Can never include infinity. But is there an equal sign on the original problem? Yes, so I can include the intersection. Now, let's play the what if. What if it had said less than or equal to? Then in that case, it would be this bottom part, and your domain restriction would come into play, and your answer would be from 2 to the intersection. And since there's an equal sign at the intersection, you can have a bracket.